Hey everyone, welcome to another calculus video. This is section 2.5, limits at infinity. The last section was 2.4, infinite limits, and that was when the y values went toward infinity. This is limits at infinity, where the x values are tending towards infinity. So graphically, what does this mean? This means we're looking to see what happens to the graph as you go out this direction, x going to infinity, or out this direction, x going to negative infinity. So that's what we're really looking at, kind of the end behavior of the graphs, if you will. And one key fact that we need to help us to do this, this is the one key item or idea that we need, and that's this, that the limit as x approaches infinity, plus or minus, either one, of a constant over x to a power is always equal to 0 if r is a positive exponent in the denominator here of x. So basically what we're saying is if you have a number, no matter how big this number is, if you're dividing by something that's going to infinity, then obviously that gets smaller and smaller and smaller, and it eventually goes to 0. So this key fact here, this key item for this section is going to be kind of what drives everything that we do. Okay, let's do an example. So the limit as x goes to infinity of x cubed minus 3x squared. Well, if you're just looking at it like this looks like, well, as x gets big, x cubed gets big. As x gets big, x squared gets big. This kind of looks like infinity minus infinity, but that's an indeterminate form. That doesn't make any sense. So what I'm going to do is I'm going to factor out the largest, not the smallest, not the greatest common factor, but I'm actually going to factor out the largest power of x. Now, how do you do that? Because if I factor out x cubed from x cubed, I'm left with a 1. But if I factor out x cubed from 3x squared, how can I, quote, factor that out when the x cubed is more than x squared? Well, factoring just means dividing out or undoing the distributive property. So if I'm dividing away, 3x squared divided by x cubed gives me 3 over x to the first power. 2 in the top, 3 in the bottom. 2 minus 3 gives me a -1 or an x to the first in the denominator. Okay? So now what I can say is x cubed is going to infinity. 1 is just 1. 3 over x is going to 0. That was my key idea, right? The key item that said if you have a constant over x to a positive power, as x goes to infinity, that goes to 0. So this becomes 1 minus 0, so I just get infinity, positive infinity in this case. Okay, now you don't have to do it this way every time, but basically the idea is this, is that x cubed, right, is x times as much as x squared. So if x is 1,000,000, x squared is 1,000,000 times 1,000,000. That's big. But x cubed is 1,000,000 times more than that. And so that's a lot bigger. So the cube takes over versus the squared, and that's emphasized here by factoring out the highest power. So you're always looking for the highest power of x. Always want to look for that, and then factor out the highest power of x with the understanding that that's going to give you some x's in the denominator, ideally, and then you can use the key fact, the key item that we've been talking about, okay? So here is a second example. What's the highest power of x here, top or bottom? Again, x cubed. So I'm going to divide the top and the bottom by x cubed. I'm going to factor out an x cubed, if you will, from each one. How does that work? Well, if I divide x squared by x cubed, I get 1 over x. If I divide 1 by x cubed, I get 1 over x cubed. If I divide x cubed by x cubed, I get 1. If I divide 4 by x cubed, I get 4 over x cubed. As long as I do the same thing to the top and bottom, that's legal. And now as x goes to negative infinity, this goes to 0 plus 0 up top. This goes to 1 plus 0 on the bottom. And so we get 0 over 1, which of course is 0. And that's my final answer for this limit. Okay? So that's the basic process. You guys try one. All right? This is a similar idea. Limit as x goes to infinity of 2x minus x squared divided by 3x squared plus 1. Pick the highest power, factor it out, or divide by it, however you want to think about it. I gave you 2 examples, one of each version. You guys pause the video and give it a shot. Okay? So if we identify what the highest power is x squared, so if we factor that out of the top, we get 2 over x first, and we get minus 1 there. If we factor out an x squared in the denominator, we get a 3 and a plus 1 over x squared. So you see the two differences here. Here the x squareds divide away. You can either factor it out or you can divide by it if you'd rather. Okay, you can think about it either way. Okay, think about it either way. So take that away for a minute, but just making sure you realize we're doing the same thing. Okay, so what does this give us? This gives us the limit as x goes to infinity of 2 over x minus 1 over 3 plus 1 over x squared. I know this is a complex fraction, but that's okay because I want these guys over x and x squared because they go to 0 as x goes to in positive or minus infinity. So we get 0 minus 1 over 3 plus 0. We get negative 1/3 as this limit. Okay? So simple enough, this process. And just like infinite limits gave us information about vertical asymptotes, a function will have a horizontal asymptote if you have a limit to infinity from either side. Limit as x goes to infinity or limit as x goes to negative infinity, you'll get an asymptote of y equals L if L is your limit. So you do this one. Find any horizontal asymptotes for the graph of f of x equals 2x minus 1 over x plus 9. All I'm going to do, I'm just going to take the limit as x approaches infinity or negative infinity, either one. In this case, it's going to be the same thing. So you can just take a look at the limit as x goes to infinity of f of x. And then you just have one extra step at the end to report your answer properly because horizontal asymptotes are lines just like vertical asymptotes are lines. And so when you're reporting asymptotes, you always have to give me an equation. Okay? So pause the video and see what you can do here. Okay? So once again, we're going to take the limit. We're going to divide top and bottom by x. 2x minus 1 divided by x, because that's the highest power. X plus 9 divided by x. And so we get the limit as x goes to infinity. 2 minus 1 over x, all over 1 plus 9 over x. And so this becomes 2 minus 0 over 1 plus 0, and that's a 2. Okay? And so that's not my answer, though. Find any horizontal asymptotes. Horizontal asymptote at the line y equals 2. That's my answer right there. Okay? Now, some of you are thinking back to your pre-calculus days and you're like, wait a minute. I remember the higher power thing, the degree thing, and these degrees are the same, x to the first, x to the first. So I just take the leading coefficients. 2 over 1, I get 2. Ta-da. Or the higher power is on the bottom, so it's just 0. Y equals 0. Ta-da. All right. Well, that's great if you're in pre-calculus. You're not. You're in calculus. And the reason is that not all of them work this way. So I promise not to give you a difficult one if you show me the work. But if you just look at the coefficients and you just report y equals 2 with no limits as x goes to infinity at all, you're not going to get credit for it. Just like you're not going to get credit for the vertical asymptotes if you don't show me infinite limits. And so here's an example of why. Here's a special case. All right. What's the highest power here? This is 2 to the x power, x to the first on the bottom, x squared on the top, but it's underneath the square root. Remember, square root's a half. So 1/2 and a 2, they kind of cancel each other out. And so the highest power of x here is x to the first power. So I'm going to divide top and bottom by x. Well, that's fine, except that x can't go underneath the square root. But remember what x is. If x is positive, x is the same as the square root of x squared. So on the bottom, I'm going to divide by x, but on the top, I'm going to divide by x squared underneath the square root. And so I get square root of 1 plus 1 over x squared. This is only true for x positive, so or x greater than or equal to 0. That's why I'm making sure you see that. Square root of 1 plus 1 over x squared. Here we get 2 because I divided by x. And so I get the square root of 1 plus 0 all over 2, which is 1 over 2. Simple enough, right? Well, what if we do that down here? What if we're taking the limit as x goes to negative infinity? We're still going to divide top and bottom by x. But now if x is less than 0, x is not equal to the square root of x squared. That's not true. Negative x is equal to the square root of x squared, because this square root is a positive square root, and so you get the negative version of x, because x is a negative, two negatives make it a positive. And so up here then, I have to take that negative sign, put it on the other side. X is equal to negative square root of x squared, and so I get the limit as x goes to negative infinity. Square root, I'm dividing by, remember, negative square root of x squared, so I put a negative out front, and I get 1 plus 1 over x squared. On the bottom, I get regular stuff, 2, and so I get negative square root of 1 plus 0 over 2, and so my answer now is negative 1/2. This guy has 2 horizontal asymptotes. Y equals 1/2, and y equals negative 1/2. There's 2 of them. All right, now again, I'm not going to do that to you, but this is why I'm such a stickler about you showing me the work. If you don't show me the work, if all you do is say there's a 2 in front and a 1 in front, 2 over 1 is 2, done. If that's all you do, that was great for pre-calc, that doesn't work in here. And this is why it doesn't work. Okay, so I promise not to give you a problem like this, but I also promise not to give you points if you don't show your work here. Okay? So I hope that helps. Do the practice, do the My Math Lab, and we'll see you later. Thanks.